Welcome students. The topic of today's lecture is lubrication. What is lubrication? Here we take an example of two mating parts, part 1 and part 2. This is the microscopic view of mating parts, and at microscopic level we can see that these are the two parts. We see small rough crests and troughs at the surface of these mating parts. So, at this microscopic level we can imagine that when these parts rub over one another, these crests and troughs, they will interlock with each other if there is not any lubrication, which will result in wear and tear and loss of power. So, the main role of lubrication is to provide a film between these mating parts in order to provide the smooth movement of these mating parts. The lubricant fills these crests and troughs and provide a film between these parts, and thus reduce the power as well as the heat loss. Next we will see the definition of lubrication. The definition says the process of introducing a film of lubricant between the moving parts to reduce friction is called lubrication, as we have seen earlier. Some of the functions performed by lubrication is, first is to reduce the friction, to minimize the wear, to produce the cooling effect. When the lubricant is introduced between the mating parts, it takes away some of the heat produced due to the movement of the parts, and that thus provides the cooling effect. And next is to provide an effective seal in case of piston cylinder arrangement. The lubricant fills between the piston rings and the cylinder liner and provides a effective seal during the expansion stroke. Next is to carry away the impurities. As there are number of parts in an engine, while moving it emits small particles of wear and tear, that is called as impurities, and also the products of combustion. So, the lubricant takes away those impurities to the sump where all the lubricating oil stores. Next is to provide the cushioning effect. Cushioning effect means that when the engine runs, there are number of vibrations, and when the film comes between the mating parts, it also takes away some of the vibrations and thus provides the cushioning effect. And next is to protect against corrosion. The lubricant forms a film over the moving parts and thus reduces the process of oxidation and also the corrosion. Next is to reduce the noise. As said earlier, it absorbs the vibrations, therefore, it also reduces the noise produced by the engine. To resist the oxidation, it protects against the formation of sludge, soot, lacquer formation, as it covers the moving parts. And next is to absorb the harmful substances like unburnt carbon particles, hydrocarbons during the expansion stroke. It dissolves all these particles and bring it to the sump. Next we will see the type and properties of the engine lubricants. The lubricant is a substance inserted in between the moving surfaces or moving parts to reduce friction, and it is called as a lubricant. Lubricants are classified as solid lubricants, semi-solid lubricants and liquid lubricants. Under the solid lubricants, there are graphite, molybdenum and mica, which are mixed in the powdered form with the oil and are used for automobile spring lubrication. Semi-solid lubricants, as you are all aware, you have seen greases, they comes under semi-solid lubricants and are also used for lubricating the steering linkages and other moving parts of an automobile. Third category comes under the liquid lubricants, and under this there are three types: animal oils, vegetable oils and mineral oils. The first two categories are not used for the lubrication purpose, as these are light oils and they also have the property of mixing with the water. So, they are unsuitable for lubrication process. And the third category, that is mineral oils, is used for lubrication process, and these products are derived from the fractional distillation of the petroleum products. Now, we will look at some of the properties of the lubricant which they should possess. First is the viscosity. Viscosity is the property of oil which measures its resistance to flow, and this is inversely proportional to the temperature. As the temperature rises, the viscosity of oil reduces. So, a lubricant should provide a optimum viscosity at higher temperature. That lubricant should be used for that purpose, and it is measured with the help of a device which is called as viscometer, and it is measured in say seconds Seabolt or seconds Redwood. There are two apparatuses for measuring viscosity, Redwood viscometer and Seabolt's viscometer. The viscosity of lubricating oil determines the case with which the engine can be cranked in winter. As the viscosity is inversely proportional to temperature, in winters the oil become more viscous. So, it should be kept in mind the range of viscosity of the oil should be optimum in winters as well as in summers, and it also affects the generation of power output. More viscous oil, it will require more cranking effort, and it also should provide the sealing ability and the load carrying capacity of the lubricating oil. Next property is the flash point. Flash point determines the lowest temperature at which the lubricating oil will flash momentarily. It provides a small flash. And next is the fire point. This point determines the lowest temperature at which it will catch the fire and will burn continuously. The fire point should be at least 18 degrees Celsius higher than the flash point. Next property is the pour point. It is the lowest temperature at which a lubricant will flow or pour under specified test conditions, which is called as pour point, and this temperature shows that shows the temperature below which the lubricant will not flow. This will determine that what is the lowest temperature at which the lubricant will work properly. Next is the specific gravity. Specific gravity determines the density of the unit weight of the lubricating oil, and it is determined by the scale recommended by the American Petroleum Institute, and this scale shows the numbers in API. Next property is the neutralization number, and it is the measure of acid contents in an oil, and it is called a neutralization number. The oils with a higher neutralization number should not be used as lubricating oil, as it will result into the corrosion or oxidation of the bearing metals or the moving parts. Next is the stability. This ability of the oil shows the resistance to foaming, oxidation and carbon formation, which is called as stability. Some additives can be added to the oil to increase its stability. Next is the volatility. Volatility property determines how readily or the tendency of the oil to get evaporated. The oils with high volatility should not be used, as there will be loss of the lubricant and the lubrication purpose will not be served. Next property is the film strength. It is the capacity of the layer of the lubricant. It is the capacity of the layer to withstand high loads, because as in an engine there are number of parts like the crankshaft and the crank pin where the load comes, because during expansion stroke the load comes over the crank pin and the lubricant is there. So, the lubricant should have a proper film strength. It should not break away under some load. Next is the precipitation number. Precipitation number shows the volume of sediments or the precipitate in a used lubricating oil. The precipitation number shows the sediments accumulated during the use of an oil. Therefore, it is recommended that the oil should be changed when the precipitation number exceeds a certain limit. Next property is the oiliness. This property of the oil states that the oil, how ready the oil is spreaded and sticked around a bearing surface. This property should, when the mating surfaces are subjected to heavy loads and pressures, oils with high oiliness should be used because they will readily stick and spread easily to the lubricant to the various parts and provides lubrication under high pressure. Next property is the emulsification. Emulsification property is how readily the lubricating oil dissolves in water, and oils with high emulsification, as said earlier, like animal oils and vegetable oils, they shouldn't be used because if they will their high emulsification, they will get dissolved in water and will not serve the purpose of lubrication. Next property is adhesiveness. Adhesiveness is the property of the oil with which it will stick to the metal surfaces to which the lubrication is to be provided. Next property is physical stability. This property shows the lowest and highest temperatures with which the oil is to be used, and it shows the physical ability or physical stability of the oil. Oil with good physical stability should not vaporize, as said earlier, at highest temperatures, and it should not have separation of products at lowest temperatures. Next property is the chemical stability. The property of lubricating oil to have a least tendency for oxide formation, that is, this tendency will result of the lubricating oil will result that it will not decompose at higher temperatures, because higher temperatures are there in an engine. So, the chemical stability, the oils with high chemical stability will not decompose into different products at higher temperatures. Next property is the sulphur content. It shows the minimum value of sulphur which will decrease the corrosion in the lubricating oil. It is called as sulphur content. Next property is the detergency. Detergency is the property of an oil to keep the interior of an engine reasonably cleaner. As I have told you earlier that during the lubrication process, the oil should clean the internal system of the engine. It will take away the impurities of the wear and tear of the engine. It should have a detergency property. And the last property is the insoluble residue. The property of good lubricating oil is that it should not have insoluble residue like hydrocarbons. These are the products of combustion and which will decompose into carbon at high temperatures. So, it should not have insoluble residue. These are the properties lubricating oil should possess. But in addition to these properties, a good lubricating oil, that it should be non-toxic and cheap. These are the two properties it should also possess, and no single lubricant can meet all these requirements, but we should look for the optimum values, the maximum advantages which we can take from the lubricating oil. Next we come to the lubrication system of an IC engines. There are three types of lubrication systems. First we will see the definition. The system of an engine to supply and regulate the flow and purify the oil so that proper lubrication is done to all the moving parts producing friction is called lubrication system. There are some purposes for lubrication system. First is to supply and regulate the flow and purify the oil. Purify means the detergency property, purify the oil, and also there is we will see later on there are filters employed for purifying the lubricating oil. so that proper lubrication is done to all the moving parts producing friction is called lubrication system. There are three types of lubrication systems in an internal combustion engine. First is petroil or mist lubrication system. Second is wet sump lubrication system. Third is the dry sump lubrication system. We will see one by one. First is the petroil or mist lubrication system. The petroil or mist lubrication system is employed in two-stroke engines like scooters and some motorcycles, and in which you have observed that we mix the lubricating oil itself into the petrol in the ratio of 3 to 6%. There are some advantages of lubricating this lubrication system, petroil lubrication system. Some advantages are lubrication system is simple, we will see later on. It has low cost and it does not require oil pump and oil filter, but there are certain disadvantages. It produces heavy smoke because the lubricating oil also burns with the petrol itself. The exhaust smoke forms deposits over the piston crown and the interior of the cylinder block. The oil comes in contact with acidic vapors produced during combustion. This corrodes the bearing surfaces, and during downhill, when we come downhill with a two-stroke engine, the throttle remains closed. So in that case, the charge which is mixed with the lubricating oil does not come inside the engine, and that means the lubrication suffers, lubrication become less when we come downhill. So this is a disadvantage of this lubrication system. This diagram shows a cut section of a two-stroke petrol engine. We can see that this is the carburetor from where we get the charge. The charge is that is petrol, and the lubricating oil comes. Here is the throttle valve, comes to the inlet port. Inlet port, when the piston moves upwards, suction comes here. The charge comes into the crankcase here. When the piston moves downward, the compression is there. The charge moves upward to through the transfer port above the piston and get compressed, and with the help of spark plug we give the spark and the mixture is ignited, and again we get the power stroke. This is the exhaust port through which the exhaust gases move. But here we can see that the lubricant is also coming along with the petrol into the crankcase. It also serves the purpose of lubrication here. This is the crankshaft. It gives the lubrication also, but it goes along with the petrol through the transfer port to the ignition chamber, and here lubricant also burns with the petrol, and hence the smoke is there, and also forms a carbon deposit over this piston and the cylinder blocks and all this area. This is the main parts of a lubrication system. We will see. This is the oil sump. This is the lubricating oil. Here oil screen or strainer is shown. The strainer, the purpose of the strainer is just like a filter. It does not allow the sediments which is settled here to the oil gallery. Next comes the oil pump, which pumps the oil to the gallery. Here is the oil pressure relief valve. We will see later on the detail of this, and this hole is the oil gallery. The arrow shows the paths of the oil, and here is the pressure gauge which shows the pressure of the lubricating oil inside the gallery. The oil then goes through the oil filter, gets cleaner and comes towards the oil sump back. Now we will see the different types of lubrication system. First we have seen the petroil or mist lubrication system. Now I will see different lubrication system of some 4-stroke engines. First one is the splash lubrication system. Here also there is a sump, contains the lubricating oil. Oil strainer, oil screen is here, and here is the oil pump. The oil is pumped here. You can see these dotted lines. Here are oil troughs or small containers of oils which gets filled with the supply from this oil pump. These are called oil troughs, and we can see here is the crankshaft, and this is the connecting rod, and this is the piston. Under this crank pin we see small scoops. Here will also come, here comes also some other pistons, but this is the one case. These are small oil scoops. When the piston comes from top dead center to bottom dead center, these oil scoops passes through this oil and give it a splash. This is a common example. When you throw a stone into water, you observe a splash comes out of it. So here is the case also. The scoop, these scoops, when passes through the oil, gives it a splash. You can see this splash all over here. The splash gets scattered all over the crank pin, connecting rod, and all the parts. Here is the camshaft, and because of this splash, which is scattered all over the moving parts, the parts get lubricated, and this type of system is outdated. Next come the combination of splash and pressure lubrication system. In this, again the oil sump, the lubricating oil, oil strainer, oil pump, but here the oil troughs are missing. But instead of that, we can see these dotted lines. This is the oil gallery, and here are small nozzles. Here are 1, 2, 3 and 4. Here are small nozzles through which oil is pumped. Because of the pressure of this oil pump, oil is pumped out and again scattered all over the crank pin. But in addition to that, you can see here are the paths which lead to the crank pins. The paths are here for lubricating the crank pins, and in addition to that, oil gallery goes all over the camshaft, lubricating the bearings of the camshaft and also the tappets assembly and the cams. So these are the paths formed, but in the previous case these paths were not there, and only splash provides the lubrication. So this type of system comes in combination with the splash. Here is the splash. You can see the nozzle is here, the splash is there all over here. But in addition to that, the gallery also provides the lubrication under pressure to the camshaft and the crank pins. So this is the combination of the both splash and pressure lubrication system. Next type of lubrication system is pressure feed lubrication system, where the both are missing. There is no nozzle and no oil troughs. All of the oil is under the pressure. The galleries are provided at the same place, like here. This is the oil pump, oil strainer, oil pump, and this is the main gallery, and these are the branches of the galleries. From here it comes here at the crank pin, and we can also observe that the oil is also moving from this point to this point also, that is the adjacent crank pin, and here also this is the centralized, and from here the oil goes to this crank pin as well as to this crank pin. Here the holes are drilled inside the crankshaft. The oil first comes here, and from here through that drilled hole the oil goes to this point, but in the previous case it was not there, and similarly here and similarly here. All of the crankshaft is properly lubricated under pressure. This is a pure pressure lubrication system. The oil comes under pressure and is provided to all the points, and also you can see that oil is going here also to the bearings of the camshaft and tappet, and this is the pressure gauge, oil pressure gauge, which will measure the pressure of the oil gallery. This will also show if the pressure here exceeds a certain limit, you can check the gallery if there is any blockage in the gallery or some other problem with the pump, or otherwise you have to check all the circuits of the oil gallery. Third type of lubrication system is the dry sump lubrication system. As we have discussed all the lubrication systems earlier, those lubrication systems are concerned with the engines, automobile engines, but in case of aeroplanes or the jet engines, there is a problem when they take off and when they land. The whole of the plane gets inclined at an angle. So, if we employ the previous type of lubrication system, the oil level will divert, it will not provide proper lubrication. So, in that case, we will continuously supply the lubricating oil to the engine with the help of a dry sump. Dry sump means the sump is not accumulating any lubricating oil, but the pumps employed in this type of lubrication system continuously provide the lubricating oil for the lubrication purpose. We will see in this diagram, all the lubricating oil is stored in this supply tank, and from here the oil is taken. Here is the oil pump, and you can see here is a pressure leaf valve. The purpose of this pressure leaf valve is only to open when there is high pressure on this supply line, and it will divert the oil pressure to the back side of this intake line. This oil pump takes the oil and supply it to oil cooler. Oil cooler will cool the oil if it is raised to a certain temperature, and it will again provides the oil lubricating oil to the bearings or other moving parts of the engine. After that, the lubricating oil falls to the engine's crankcase, and from that crankcase it is continuously sucked by another scavenging pump, but in previous case it was continuously stored in the sump of the automobile engine. In this case, the oil falls in this sump. That is why it is called as dry sump, because it does not store any lubricating oil, and that is why it is a dry sump. The oil which will fall in this sump is continuously taken away by this scavenging pump through this strainer and a filter which will filter the any residue or the products of wear and tear. And again, here is a pressure leaf valve or filter bypass pressure leaf valve. If the pressure here increases, this valve will open and it will again bypass the pressure of the lubricating oil, and from here the oil will again goes to the supply tank and store here. So, here we can say that this supply tank accumulates all the lubricating oil, and these two pumps gives continuous supply to the lubricating parts of an aeroplane engine. That is why this is called as dry sump lubrication system. Now, we will see some of the parts of the lubrication system. Here is a pump which we have seen in all the lubrication systems. This is a gear type pump. You can see here there are two gears, 1 and 2 meshed together with each other, and these gears, one is driven, other is the driver. The drive is given to only one, other is the driven. When these two move, rotate in different directions, the vacuum is created between these cavities of the gear, and due to this vacuum created, the oil is taken to these cavities and is again pumped by these lobes of the gears and supplied to the delivery line. See, the operation is very simple. Two gears move and vacuum so created drives the oil into this chamber and is pumped and again delivered to the delivery line. Here is again a pressure leaf valve, spring loaded pressure leaf valve, a ball is provided here. If the pressure in this line exceeds certain limit, this ball will be raised against this spring and the oil will be bypassed to the intake line. This is called as gear type pump. This is the oil